Hello students, welcome in chapter 11, 3 dimension geometry. Students, today I continue our exercise 11, question number 18. Find the distance of the given point to the intersection of the line and the given plane. So first of all students, I decided intersection between line and plane, it means one point forming, and that point at distance create to given point. It means your drawing is that is your considered plane, and plane is given that 1x means x minus y plus z is equal to phi, and here one line passing through on it, maybe point is P, and that distance create to the given points Q is that minus 1 minus 5 minus 10. It means I will decide it first of all intersection point P. So very easy, our given line L is a r bar is equal to 2 minus 1 2 plus lambda 3 4 2. It means we write down only 2 plus 3 lambda minus 1 plus 4 lambda and last 2 plus 2 lambda, and r bar is equal to, I just write down x, y, z. It is a point forming point form. It means line L, I will decide it in the point form. Now this point P is intersection with the given plane and decided exactly value of the P. So students, now this point P, I just lies on this given plane. So I just continue. Now line L intersect with the given plane. Plane is that x minus y plus z is equal to 5 and is equal to point P. That's my xyz. Indirectly students, I telling that this point P apply on the plane. So x minus y plus z is equal to 5. X put, y put and z putting. X is a 2 plus 3 lambda, y is a minus 1 plus 4 lambda, and last 2 plus 2 lambda, and decided value of the lambda. So 2 plus 3 lambda plus 1 minus 4 lambda and 2 plus 2 lambda. So 2 and 3 5 minus 4 it is lambda, and here total 5 is equal to 5. So does lambda become 0. Now this lambda again put here. So intersection point is that P xyz is clearly known now. 2 plus 3 lambda comma minus 1 plus 4 lambda comma 2 plus 2 lambda. So it get 2 minus 1 2, and that point I plot here 2 minus 1 2. Before I going that distance, I decide P. Now P to Q distance formula. So my last answer, required distance, it become PQ distance. Apply the distance rule. So here 2 plus 1 square, next minus 1 plus 5 square, and lastly 2 plus 10. So my answer is a 3 9 16 and 12 144. It become 169. It means 13, and that the students your PQ distance is covered that easily. Now I going ahead slowly. Question number 19. In 19 also very easy and simple sum. So now we'll continue students. Question 19. Find the vector equation of line passing through 1 2 3 and parallel to both given planes. Yes students, parallel it means I will decide it first both normal and both normal cross direction, just like that. That is your first plane normal, that is the second plane normal. I want to third, it is parallel to both. It is surely you can create n1 cross n2. So first of all plane 1, I have plane 1 is given, that one r dot I minus j plus 2k is equal to 5. It means x minus y plus 2z minus 5 is equal to 0. X minus y plus 2z, and here plane have normal radii that n1 normal is simple 1 minus 1 2. Similarly, going ahead to plane 2, and my plane 2 is r dot 3i j and k is equal to 6. So here students, 3x plus y plus z is equal to 6, and that become normal n2 3 1 1. Now I want to directions for both of the parallel. So direction of required line L, which is clearly given, which is parallel to both plane. Yes, which is parallel to both given planes. That's why L direction we will write down n1 cross n2, and both cross directions, it is surely directions to parallel on it, and very easy. They cover to your determinant solutions. So L directions n1 cross n2, we will show that first cross second. My first normal is that 1 minus 1 2, and second 3 1 1 already be written here, and go to ijk, and that is the same 1 minus 1 2 and 3 1 1. Simple, calculate. So it is I minus j and the k, so that's become answer minus 1 minus 2. Next 1 minus 6, and last 1 plus 3, it is minus 3i. Next 5j plus 4k. That is the direction of required line, parallel line to both planes. Now required vector equation of line passing through, where it is passing through. Yes, check the question. Passing through given 1 2 3. So I will write down here 1 2 3, and this is the directions. So r bar is equal to a bar plus lambda l. Just put down a is your 1 2 3, so 1i 2j 3k, and plus lambda direction is a minus 3i 5j plus 4k, and that should be your answer for vector equation of the line. Yes. Now students, I will going ahead our question number 20 20 also, there is the two lines given and defined according to required my questions. Now continue students, in question 20 is similar to 19. Find the vector equation of line but passing through 1 2 minus 4 and perpendicular to given two lines. Students, here given two lines means that is the line first L1 and second line M. Both lines have I want to perpendicular on it. It means this line N, it is perpendicular to both planes. Surely the direction is N, definitely L direction cross M directions. We will both are the cross products. For the normal, here directions ready, 3 minus 16 7, and next direction is a 3 8 minus 5. So very easy. First write down direction of line L, which is L directions 3 minus 16 7. Similarly, direction of line M, which is M direction, is 3 8 minus 5. Now I want to both perpendicular on the third direction. It is that is your L directions that is your m directions, and this direction is, students, your perpendicular to both one. So I will go to cross products. So direction of perpendicular line to L and M, which is n directions, L cross M, and apply on it just simple cross products. You will know that L direction is a 3 minus 16 7, and next of the 3 8 and minus 5. Students, you are given clearly passing through. Yes, passing through given means here the point is given 1 2 minus 4, and that very simple. But first I decided our directions for line N, then after I will create my answers. So N normal ijk, that should be 3 minus 16 7, and next of the 3 8 minus 5, and simple calculate I minus j and last of the k and calculate my answer. So 16 5s are 80, 7 8s are 56. Second, minus 15 minus 7 3s are minus 15, and 7 3s are 21, and last 8 3s are 24 plus 16 3s are 48. So my answer is 80 minus 56. Very easy, students. Here 7 and 10, 6 4, and here 2 24. I think it is a multiple of 12 coming. Next year minus minus plus, it get to 5 plus 1 6, 36j. Yes, and last 24 and 48, it will be 12 1 72k. Yes, you students, common taking is better idea. 24 36 and 72. Here common taking your 12 2s are 12 3s are, and 12 6s are. And now cover to passing through known 1 2 minus 4. So required line passing through your A bar is given, that, students, is the clearly 1 2 minus 4, and that directions. Students, 12 is the overall common taking. 24 3s are 36, and 12 6s are 72. So I just write down n line is a r bar is equal to a plus lambda n directions, that is n directions. So your answer is a 1i plus 2j minus 4k plus lambda. Here 12 times extra right outside, it is indirectly I just collaboration to lambda, and 2i plus 3j 6k. Students, here you will cover to only one constant there. So my answer is 1i 2j minus 4k, and here lambda is uniquely covered to in the lambda, so it is only constant there, lambda 2i 3j 6k, and that is your, students, final answer to question number 20. Now after that, students, I going ahead our question number 21, which is IMP for board exam. Yes, question number 21. So now, students, continuing 21, prove that if a plane has the intercept ABC is a distance of a p units from this line origin, then prove that 1 by a square plus 1 by b square plus 1 by c square is equal to p square. Students, this ABC is a intercepted parts of the given planes, that is your plane. Consider your z, x and y, and that's your intercepted parts. I will just show that ABC. A0 0, 0B 0, and 0 0 C. So very easy, equation of plane, you know that. Yes, equation of plane having x intercept small a, y intercept small b, and z intercept small c is x by a plus y by b plus z by c is equal to 1. I just take 1 inside. So your plane is x by a plus y by b z by c minus 1 equal to 0. This plane and distance from origin is given that p. So now distance from origin is p given that, so might apply distance formula, x1 by a, y1 by b, z1 by c minus 1 upon under root, you are going to L square, m square and n square for the directions values. Very easily you will prove now your answer, students. So here what's the L? 1 by a the whole square, 1 by b the whole square, 1 by c the whole square. So our answer is a simple way. x1, y1, z1 is a distance from origin. So your p is equal to 0 by a, 0 by b, 0 by c minus 1 by under root 1 upon a square, 1 upon b square, 1 upon c square. And simple, you calculate squaring on both sides. After that just I return in the form of 1 by a square, 1 by b square, 1 by c square and make the cross multiply. So under root 1 over a square, 1 over b square, 1 over c square is equal to minus 1 in cover to 1 by p, and take both sides squaring, you will cover the answer. So both sides we taking square. So 1 upon a square plus 1 upon b square plus 1 upon c square is equal to 1 upon p square. And here students your answer is very easily and happily students here done. Now after that we going ahead question number 22. That also very simple and easiest one. Now students, next question 22. Find the distance between two given planes, plane 1 and plane 2. You first check your coefficients all are same. Yes, if you create then it is same. So I just write down here multiply by 2. So my plane 1 is covered to 4x, 6y, 8z, and here 4 to the 8 take inside. And plane 2 I will show that same is 4x plus 6y plus 8z minus 12. Indirectly students check here both normal is same. So your both plane is parallel. Your first plane and second plane. Both normal is same. So both plane are parallel. The distance is covered to point A to point B is very easy. Therefore both distance AB distance generally d1 minus d2, this d1, this d2, either this d1, this d2 by under root L square plus m square plus n square, and apply the distance formula very easily. Distance between two planes, d1 is a minus 8 but d2 is a minus 12 by under root same as 4 square, 6 square, 8 square, and you just calculate in the simplest form your answers. So my total calculations is that AB distance minus 8 plus 12 by under root 4 square 16, 6 square 36 and 8 square 64. It is 4 by under root here 100, 116, 116. Sure it covered to 4 into 29, 9 for the 36, 3 carry, 4 to the 8, 8 and 11. So 4 by 2 root 29. So my distance is 2 by root 29. That's your AB answer. Very easy, but students necessary you will first create both of the your normal form are same. That's why I create multiply by 2. Next students, question is 23 is just define the MCQ to given plane between, we just covered two. It is a perpendicular on it, it's a parallel, or intersection with y-axis, either passing through 0, 0, 5 by 4. My two plane is a given plane 1 and plane 2. Don't worry students, I will write down both and all options also there. First plane is a 2x minus y, 4z minus 5 is equal to 0, and second 5x minus 2.5y plus 10z, yes, minus 10 is equal to 0, and options are there, our four options. First of the, it is perpendicular planes. Second given, it is a parallel planes. Either given third, intersect with y-axis, and last given passing through 0, 0, 5 by 4. So students, first of all I create of the both our normals are same or not, I checking this and this, I same checking or not. First I calculate plane 2. My plane 2 is a 5x minus 2.5y, 10z minus 6 is equal to 0. I just show about that in this forming. Just of all divided by each term to 5, that is 25 by 10, 10z minus 6, this cancel. So 5x, 5 5s are 5 2s are. Students, here you just divided by 5 to each term. Definitely x minus 1 by 2y, 5 divided means 5 2s are, here 5 divided. Just only I divided by 5, 5, 5. Now check, this and this are same. Yes, same if you take LCM 2. So 2x minus 1y, check, plus 4z minus 12 by 5. And definitely this plane normal and this plane normal, students, indirectly same. It means both planes are definitely parallel. Both normal are same. This normal n1 and this normal n2 are to equal each other. Therefore I just write down my answer is what? Parallel planes. Yes. So here normal n1, this normal 2 minus 1 4, and second normal n2 2 minus 1 4. Indirectly students, the previous questions and this question are same, and here students we will show that both are parallel planes, and you will tick that. But if you not parallel, then you will check n1 and n2 both dot product 0, and if you create dot product 0, then the answer is what? Perpendicular. Then after the creation of y-axis and passing through on it. Here students, our exercise question 23 is done, and our this chapter also students happily over here. Now I explain further explanations to our new chapter. Okay, bye bye.